Hello and welcome to part 2, going over the chapter 7 unit guide. I wanted to make sure that I covered all of the topics. So in part 1, I'm going to quickly review that and then go on to part 2. Okay. All right. So in part 1, we went over the first page where we talked about finding molar mass of a compound. What if we had just subscripts with parentheses? And then what if we had a coefficient? How do we distribute that? We went over how to do grams to moles, problems of a single compound or element, and mole to grams. We also went over an Avogadro's number problem. So make sure you pause the video if you need to see that work. Then on the next page, we did some compound or some individual elements, converting them from mass into moles, which is similar to what we did on the previous page. Then we talked about percent composition. So let me zoom this in a little bit so you can see the math a little bit better, where we take the number of elements in the compound, we multiply it to get the amount of how much we have, and get the molar mass of the entire compound. Once we have the entire mass of the compound, then we can take the individual mass of each element, divide it by the molar mass times 100, and get the percent composition. So go ahead and pause the video here if you need to review that. All right, moving on. On the last page, this is where the part 1 kind of got cut off a little bit. Here we went over the vocabulary, so make sure you have that filled out correctly. I got to the first empirical formula, where step 1 was taking the masses given, dividing by the individual atomic mass to get to moles of the substance. You find the smallest mole number out of all of them, divide everything by that mole number, and hopefully get whole numbers, because your step 3 would be writing the formula. If you don't get whole numbers like we got in this problem, we had to do the multiplier step, which is like step 3a, and you have to multiply by a whole number to get all your numbers to whole numbers. So we did that, and by multiplying by 2, we got whole numbers. So it was Na2, S2O3. So let's do the last 2 problems. 9 and 9, you have 1 and 2 on this one, so A and B. So here we're given percent composition instead of masses. Well, we can just convert these to masses because they add up to 100%. If they do, then we can just put them as the mass. So it looks to be, we have lead would be 86.6 grams divided by the mass of lead, which is 207.20 grams. And let me go ahead. Sorry about that. Let me go ahead and do the next one before we move on. Sulfur can be 13.4 grams divided by the mass of sulfur. All right, so let's do that math. Let me get my camera situated here. Okay, so we have 86.6 divided by its mass gives me 0.41795 mole. And then 13.4 divided by its mass gives me 0.41783 mole. Okay. All right, let's do step 2, which is to take the smaller mole number, and it looks like it's going to be the bottom one here. So 0.41783 and divide by 0.41783. Obviously, when we divide the same number, we're going to get 1. This is close enough. It's going to be like 1.01. So that's going to actually round to 1. So the empirical formula is just PBS. Okay? So there we didn't need to do the multiplier step. All right, and then in the second problem, let me move this over just a little bit. We have these percentages, and when we add them all up, they add up to 100. So let me go ahead and do the calculations. We've got BA is 69.59 grams divided by its mass, 137.33 grams. And then we've got carbon at 6.08 grams divided by its individual mass. And then oxygen, we got 24.33 grams divided by its individual mass. So let's go ahead and do that. 6959, 137.33 gives me 0.507, 6735, and that's moles. 6.8 divided by 12.01 for carbon gives us 0.506244 mole. And then 24.33 divided by 16 grams gives us 1.52062 mole. Now you might be thinking, how far do I go out? Well, you definitely want to go out 3, if not 4 past the decimal. You just want to make sure that you're not bringing in a possible error of where you do a multiplier step when you don't need to. So the more numbers you can go out, the better. That's why it's always good to have a scientific calculator. You can see all your numbers, okay? So obviously the smallest one is going to be the middle one. So I'm going to put that number 506,244, 506,244. That's going to definitely give me 1.506,244. So let's do the math on the other numbers. So 0.506735 divided by 0.506,244. That is close enough. I mean, wow, it's right on the nose. We don't even have to try it around. It's 3 past the decimal zeros. So 1.52062 divided by 0.506,244. And this is 2 zeros past the decimal. So even though you wanted to round, 3 is not going to do anything to the 0. So we have 3. So we don't have to do the multiplier step on this one either. So another thing you have to remember is that the order that they're listed, that's the order that you write the formula. So it's BaCO3. Okay? All right, and then the last part here was where you had to do the whole thing. I believe I did this in class with you. Let me try to straighten this out a little bit. This is where we had to first find the empirical, and we did that. It was CH2O, and then from the empirical, we find the empirical molar mass. Once we have that, you're given the molecular mass in the problem. You're going to divide those two, molecular divided by the empirical, to get a whole number. Once you get that whole number, you're distributing that to all of the elements. So we actually get C6H12O6. All right, so I hope this has helped you with mole to mass to mole, molar mass calculations, empirical formula, and molecular formula. So this covers all of Unit 7, quantitative composition of compounds.